Most tech creators use AI as a glorified typewriter. They open a browser tab, pay $20 a month to a trillion-dollar frontier lab, and ask a closed-source chatbot to optimize their video titles or write their video descriptions. But a few months ago, the internet's largest independent creator decided to stop renting intelligence. He decided to build it. PewDiePie didn't just build a new PC, he built a private local AI data center. We are talking about a 10 GPU monster array, 8 hardware-modified RTX 4090s, and 2 enterprise-grade NVIDIA RTX 4000 ADA cards. Total system VRAM? Over 420 gigabytes. To put that in perspective, your laptop struggles to run a heavily quantized 8 billion parameter model without thermal throttling. This rig can host multiple frontier-class open-weights models entirely in local memory, processing context windows up to 100,000 tokens concurrently with near-zero latency. Predictably, the mainstream media and casual tech channels went wild. They started running headlines about an AI council achieving emergent consciousness in a Swedish creator's basement. They treated it like science fiction. But as engineers, architects, and builders, we need to strip away the creator hype and look at the bare metal. He didn't discover a new law of thermodynamics, and he didn't invent a new transformer architecture from scratch. What he actually executed was a highly disciplined, classic systems engineering play using open-source infrastructure. And today, we are doing a complete technical autopsy on the software stack, the multi-agent orchestration loops, and the fine-tuning pipelines that turned this hardware flex into a production-ready AI operating system. Let's dismantle the most sensationalized part of this entire project, the AI Council. In his early videos detailing the experiment, viewers noticed something eerie. He set up multiple AI personas, different models representing distinct analytical viewpoints, and asked them to debate complex problems. Over time, these models didn't just debate. They began to agree, optimize each other's code, and form a strange, unified consensus. People called it machine collusion. Here is the reality check. This isn't emergent sentience. This is a textbook implementation of ensemble learning and multi-agent orchestration. User prompt, single foundation model. Output. If that single model has a structural bias, a corrupted weight distribution, or a hallucination tendency for that specific domain, your output is broken. The council architecture changes the pipeline completely. The user prompt is dispatched via an API or a local orchestrator to multiple independent local LLM instances simultaneously. Each model generates its own raw output. Then, a specialized supervisor script or a highly structured chairman LLM takes those raw outputs, acts as an evaluator, scores them for logical consistency, weeds out anomalies, and synthesizes a final consensus. Prompt: Model A, Model B, Model C, Evaluator, Chairman, Consensus. Output. Why did they start agreeing and optimizing so efficiently? It comes down to context windows. If your orchestration script appends the historical outputs of Model A into the prompt context of Model B during a multi-turn conversation, they are no longer independent. They are sharing a state. They naturally converge on similar optimization patterns because they are all trying to maximize the reward function or token scoring of the evaluator model. It's an engineered feedback loop, not a ghost in the machine, but running 3, 4, or 5 large language models concurrently on a local rig creates a massive infrastructure bottleneck, compute throughput. If you run these models sequentially, your user experience is ruined by latency. If you run them naively in parallel, you run out of memory bandwidth instantly. The secret weapon behind this entire setup isn't the raw silicon of the 4090s, it's the inference engine, vLLM. Standard model serving allocates a fixed chunk of GPU memory for a model's attention keys and values, the KV cache, for every single request. If a model has a long context window, that KV cache grows dynamically, causing massive memory fragmentation. It's incredibly inefficient. PewDiePie's system utilizes vLLM's PagedAttention algorithm. Just like virtual memory inside a traditional operating system architecture, PagedAttention breaks the KV cache down into fixed, non-contiguous memory blocks. This allows the system to manage memory with zero fragmentation, dramatically increasing throughput. It means his local rig can handle dozens of concurrent agent requests, multi-model debates, and heavy background data processing tasks without dropping the token generation speed. Once the infrastructure layer was stable, the project expanded into what tech enthusiasts called the swarm. And this is where the architecture aligns directly with the cutting edge of enterprise AI research. Instead of using a single large model to solve a massive task, the system deploys a highly distributed multi-agent layer. We are talking about dozens of smaller, highly compressed, distilled models operating in an automated production line. One cluster of agents is assigned to generate raw synthetic data. A second cluster is programmed exclusively to critique that data, looking for logical flaws or syntax errors. A third cluster ranks the data based on quality metrics, discarding the garbage and saving the premium tokens. This reflects the biggest open secret in modern AI labs: synthetic data generation. The internet is running out of high-quality, human-generated training data. The next generation of specialized models isn't being trained on raw web scrapes. They are being trained on clean, highly curated datasets manufactured by AI itself. And that brings us to the ultimate stress test of PewDiePie's rig, training his own model. There is a huge misconception among casual viewers that he spent millions of dollars training a base foundation model from scratch to compete with OpenAI or Google. That is structurally impossible for an independent creator. Instead, he did the smart engineering play: parameter-efficient fine-tuning. He took a highly capable open-weights base model, specifically from the Qwen family, and built a localized fine-tuning pipeline using a hyper-targeted dataset scraped from real-world development environments mixed with his own swarm-generated synthetic data. To measure success, the model was run against the Aider Polyglot benchmark, a brutal evaluation suite that tests an LLM's coding capabilities across 225 distinct exercises spanning 22 different programming languages. Let's look at the raw numbers, because they tell the true story of this engineering sprint. At the base model stage, using Qwen 32B in its incorrect format, the setup scored a baseline of 8% on the Aider Polyglot benchmark. Moving to the initial fine-tune run, that score rose to 16%. By the time the final optimized fine-tune was deployed, the architecture achieved a score of 39%. Look at that progression. Out of the box, due to formatting mismatches and prompt misalignment, the base model scored a dismal 8%. After the initial training passes, it climbed to 16%. By the final run, after optimizing the dataset density and adjusting hyperparameters, the model hit 39%. Now, let's apply some ruthless analytical context here. Does a 39% score on the Aider benchmark challenge elite AI coding agents? Absolutely not. State-of-the-art, enterprise-backed coding platforms operate deep in the 80 to 90% range. But what that 39% does mean is that this localized, custom-tuned 32 billion parameter model managed to beat the zero-shot baselines of major commercial frontier APIs on this specific test suite. It is a definitive proof of concept for benchmarking. Taking an open weights model, locking it in a room with highly specialized data, and tuning it to punch way above its weight class without spending a fortune on cloud compute. All of this local R&D, experimentation, and hardware optimization eventually crystallized into a real-world software product, Odysseus. Launched as a free, open-source, local-first AI workspace, Odysseus represents the structural culmination of the entire journey. On the surface, casual users might see it as an alternative interface to popular open-source front-ends like OpenWeb UI. But from an architectural standpoint, its philosophy is fundamentally different. Odysseus acts as a sovereign control layer for your data. In a standard enterprise environment, setting up an advanced AI workspace means navigating a minefield of tool integration, configuring separate Model Context Protocol (MCP) servers, setting up isolated vector databases for retrieval-augmented generation, managing API keys, and handling complex Docker containers. Odysseus abstracts that friction away while maintaining strict structural boundaries, zero telemetry, absolute privacy. The entire system operates under a local-first paradigm. Your prompts, your source code, your private documentation, and your vector embeddings live strictly within user-controlled infrastructure. No data is leaked back to a corporate mothership to train future models. Hybrid routing control. The workspace acts as a clean aggregator. It features a plug-and-play architecture where you can point the interface directly to your local vLLM or Llama CPP runtimes running open weights models. But if you hit a complex reasoning wall, you can seamlessly inject your own API keys to route specific prompts to frontier cloud labs, completely bypassing the rigid subscription gatekeepers. Built-in local RAG. Instead of treating memory as a simple chat history string, it integrates a localized retrieval-augmented generation pipeline. When you ask a question, the system queries a local vector database, pulls relevant contextual snippets from your private files, and injects them directly into the LLM's prompt window. Tacit text. Question. Now long right arrow. Text. Local retriever. Now long right arrow. Yeah text. Vector database. Extract. Now long right arrow. Our text. Local LLM. Now long right arrow. Our text. Response. It transforms the AI from a general-purpose chatbot into a hyper-contextualized private operating system designed specifically for your personal file systems and codebases. So, what is the ultimate takeaway for systems engineers, developers, and technology architects? Let's be completely candid. PewDiePie isn't competing with frontier labs. He isn't building foundation models that are going to replace trillion-dollar research infrastructures. And he doesn't need to. What this entire experiment proves is something far more disruptive to the status quo. It demonstrates that the absolute bottleneck to deploying high-tier, hyper-efficient AI systems is no longer exclusive institutional access to centralized cloud compute. The bottleneck is simply engineering curiosity and local resource allocation. 5 years ago, an architecture featuring automated multi-agent consensus loops, high-throughput PagedAttention streaming, localized vector memory databases, and customized fine-tuning runs was accessible only to well-funded AI startups and elite tech enterprises. Today, an independent content creator with zero formal background in data science can read the open-source documentation, assemble consumer hardware, build a highly performant private infrastructure layer, and distribute that sovereign software environment to over 110 million subscribers. The narrative that AI must exist solely as a centralized utility, a closed-source corporate API that you must rent forever, is fundamentally broken. Chat text, open weights, on long right arrow. Text, chat vLLM. On long right arrow, chat text, local RAG. On long right arrow, chat multi-agent framework. The future of this technology isn't just about chasing increasingly massive, expensive frontier models. The real engineering frontier is happening right here. In localized infrastructure, specialized open weights models, context-efficient environments, private RAG pipelines, and custom sovereign workflows. The transition from a passive user typing prompts into a browser tab to a systems engineer building a private compute ecosystem is the blueprint. Most people stop at the prompt window. The builders are moving into the system architecture layer. The code is out there, the weights are open, and the hardware is accessible. Stop renting your intelligence. Build it. Thanks for watching. I'll see you in the next deep dive.